So welcome to Jumbo IS and welcome to lecture number 10 of Geography and Environment in this lecture series called Prelims Powerplay 2026. Well, this is the last lecture for Geography Environment in phase 1 of this lecture series. As you all know, this lecture series would be covered in 3 phases. So we are currently in phase 1 and this is the last lecture for Geography and Environment. Next would be the test for Geography and Environment. So it's my sincere advice, be regular with the test. Now, if you are following this lecture series diligently from beginning to end, well, there are 2 advantages. Number 1, it will just take 1 hour of your day. And number 2, you will get to revise your entire syllabus for UPSC Prelims 2026. Entire syllabus by just spending 1 hour every day from now till your prelims examination. No need to get into that last minute panic situation, okay, just before your exams. Just follow this lecture series diligently from today till your prelims examination. It would only take 1 hour of your day and everything would be covered. Static plus current affairs. No need for PT 365s or monthly current affairs magazines. No, this lecture series would do. Now, to really get the advantage of this lecture series, you have to follow these 4 conditions, 4 golden steps. Number 1, watch this lecture on time every day at 9 p.m. Number 2, memorize this lecture from the notes. Number 3, you will definitely have doubts. We have enrolled you in our WhatsApp groups. Ask your doubts over there. The group is active 24/7. And number 4, well, along with this lecture series, you will get an exhaustive list of tests, test series. Be regular with the tests. So follow these 4 golden steps. That will be really useful for you. Now, the lectures would come on YouTube every day. But for tests, for notes, for WhatsApp groups, for all these 3 things, you would have to register on our app or on our website. The registration details or the registration links are given in the comment section below. Along with that, a number is also given. If you're finding any difficulty with respect to registration, just WhatsApp us on that number and we will guide you further. Okay? All right then. Enough of the introduction. Let's straight away jump into the lecture and let's talk about today's topic. So today's topic of discussion is Bharat Forecast System. Now, this Bharat Forecast System is India's own weather prediction model, climate prediction model. As you all know, Atmanirbharta is the buzzword. India wants to become Atmanirbhar in every field. One such field is weather prediction. Because Indian Meteorological Department is reliant on foreign weather prediction models, foreign climate models to predict weather, to predict monsoons, to predict cyclones. Now India has created its own weather system, its own weather prediction model. And let me tell this to you. Our weather prediction model is better than many foreign weather prediction models. So it is really good news for Atmanirbharta. And because Atmanirbharta is the buzzword, self-reliance is the buzzword these days, there is a high chance that they would ask an MCQ from Bharat Forecast System as well. Okay, so pay close attention in today's lecture. So let's begin. All right. So Geography Environment lecture number 10, Bharat Forecast System. Okay. Now Bharat Forecast System is India's very own weather prediction model. Okay. It is our own model, very different from Western systems. Now, let's gather some details about this Bharat Forecast System, which is weather prediction model or our climate model. So let's take a look at the definition first. So about BFS. So it is an advanced indigenously developed numerical weather prediction model system by India. Now the key buzzword is indigenous because that's where we become Atmanirbhar when it comes to meteorology. Okay. It operates on a high spatial resolution of 6 kilometer by 6 kilometer grid. Yes. You see, generally, the problem is that when Indian Meteorological Department makes prediction, it makes predictions for a larger area. It lacks the capacity to make localized prediction. The maximum to maximum local it can get is 12 kilometer by 12 kilometer area. Now that's a big area. An entire city can come into it. But we need localized prediction. Okay. So this BFS model has the capacity to give predictions for an area of 6 kilometer by 6 kilometer. That's a short area. We can give localized predictions for villages also. Okay, we need localized weather prediction because sometimes we give a weather prediction for a large area, But in that large area, maybe in some local areas, natural disasters would occur. And we need to warn them beforehand. So we need localized weather prediction. Now, up till now, Indian Meteorological Department was using a weather model which could give max to max weather prediction for this area. It couldn't get smaller than this. But now it can go to 6 kilometer by 6 kilometer. So it's a big improvement. So this model that we are about to use is not only Indian, that's Atmanirbhar. It's also better than other foreign models. Okay, it operates at a resolution of 6 kilometer by 6 kilometers, significantly improving the resolution from previous 12 into 12 model used by IMD. Okay, designed to provide highly accurate and localized weather forecast tailored to India's diverse geography and climatic conditions. Okay, this finer resolution allows for village or panchayat level forecast. So village level forecast, in one village, weather can be different, and in the next village next door, weather can be different. We should be able to differentiate or predict different weathers that would occur, weather events that would occur in two villages that are living side by side. This model allows that. Okay, simple. All right. Now here's the thing. Some of you might have ignored the definition. Okay, let me revisit the definition, reread the definition. It is very important. Each and every word of the definition is important. This definition said that BFS is an advanced, indigenously developed numerical weather prediction model. Now, what do you mean by numerical weather prediction model? What do you mean by numerical? So first, let's talk about this word, numerical weather prediction model. So what is a numerical weather prediction model? Listen to me carefully, okay? It is very important because technical MCQs can be asked. This, let's call it NWP, short form. So NWP is a method that uses mathematical models to forecast weather by simulating future atmospheric conditions based on current data. So basically, this model is made up of mathematical equations. Okay? Equations, for example, I'll give you an example. 2t plus p is equal to 4 ppt. Okay, let me give you just one example. 2t means 2 times temperature, p stands for pressure, and ppt stands for rainfall, precipitation. So this is a very simplistic equation. I'm just giving this equation to give you an example. Okay, so numerical weather prediction models contain many such complicated, this is a simple equation. It contains many such complicated algebraic calculus-like equations in which different variables like t, p, ppt are there. Now, t, p, ppt, what would be the value of this t, p, ppt? That would be measured by the sensors of IMD. So IMD would measure temperature, pressure, precipitation, and many other variables, put them into equations, and those equations would tell you what would be the situation 10 days from now, 20 days from now. You understand? Okay. Now this is just a simplistic equation. There are many more variables than temperature, pressure, precipitation, many more and many complicated equations. But just to give you the idea, it is a mathematical model, contains mathematical equations. And the variables in these equations, well, the values of those variables are measured by sensors. Okay, temperature is measured by sensors, pressure is measured by sensors. You get the point, right? These models divide the atmosphere into 3D grid and uses supercomputers to calculate these equations based on physics and fluid dynamics to predict how temperature, precipitation, wind, and other elements will change over time. You understand the point? Okay. Now, what is this 3D grid? Okay. The planet, the entire planet, or let's call it India, because this Bharat forecast system is for India. India would be divided into these cells, these different cells, small cells with an area of 6 kilometer by 6 kilometer. But these are 3D cells. That means apart from length and breadth, there would be height also. So it would be divided into these small cells. Each cell will be like this. Can you see over here? Right? Each cell will also have a height. It's not 2D, it's 3D. So the entire planet is divided into these cells, and weather in each cell is calculated. Temperature in each cell is calculated, pressure, wind speed in each cell is calculated, and predictions are made. You understand now? Okay. This is how numerical weather prediction model goes. Okay, so this is how a cell looks like. 3D grid of cells. Okay, and in each cell, temperature, pressure, wind, and other elements are measured. Simple. Okay, now let's move forward. How does this NWP, numerical weather prediction model, works? So first you gather data. Current weather observations, like you calculate temperature, pressure, wind speed, they are gathered and used to create the initial conditions for the model. Okay, initial conditions means what is the current situation of temperature, pressure, wind speed, etc. Okay, data is first collected and is collected from the grid system. Okay, the Earth's atmosphere is divided into 3D grids. The model calculates how conditions will change at each point in the grid. Okay, then mathematical equations which are based on physics, fluid dynamics, these complex equations that are very difficult for even a computer to solve. That is why you use supercomputers to solve these equations. Then this data is put into these mathematical equations. Supercomputer calculates these equations and predictions are made. Supercomputers, these calculations are performed on powerful supercomputers to process the massive amounts of data and complex equations required for the forecast. And the good thing is, India possesses its own supercomputers. Many countries don't have supercomputers. They have to rely on foreigners. We have our own supercomputers as well. Okay, so this is a good thing, right? Atmanirbharta, the buzzword. Now, NWP models. So there are different types of models. There are global models. Already there are foreign numerical weather prediction models that calculate the weather for the entire globe. So they have divided the entire globe into these 3D grid. These models cover the entire planet, like Global Forecast System, European Center for Medium Range Forecast. And then there are regional, like our Bharat Forecast System, which focuses on the Indian subcontinent, has divided the Indian subcontinent into 3D grid. Okay, simple? Yes? All right. Now let's talk more on Bharat Forecast System, some special features from which MCQs can be asked. Okay. So Bharat Forecast System, let's get back to it. Certain key facts. First of all, you need to know who developed Bharat Forecast System. I've told you it's indigenous. It is developed by India only, no foreigner. But which organization in India? So remember, Indian Institute of Tropical Meteorology, Pune, an autonomous institute under Union Ministry of Earth Sciences. They developed this model. So remember this. Then, what is the role of this BFS? It enhances India's weather prediction. We have discussed this, 12 kilometer to 6 kilometer. Okay. What data sources would be used? Okay. Remember I told you that temperature, pressure, wind speed would be calculated through sensors. What would be those sensors? Integrates real-time inputs from 40 Doppler weather radars. There are these radars called Doppler weather radars. Okay, which will increase the accuracy of measurement of these temperature, pressure, and wind speeds. Now, what are Doppler radars? Remember this. Doppler radars work on Doppler effect. Now, what is Doppler effect? Now, I'm going to do something funny, okay, to make you understand what is Doppler effect. You must remember this. You must have seen this also, that when you are standing on road and a car passes you by at very high speeds, okay, the sound is something like yes, yes. So the sound of this car passing you by changes its frequency, right? It is low, and when it approaches you and passes you, the frequency increases. Something like this, okay? I'm being funny. It is funny, but well, you understand my point, right? So the frequency of the sound changes because the object is in motion. Now we have scientific instruments which can measure the change in frequency, and by measuring the change in frequency, we can measure the speed of that object. By measuring the change in the frequency of sound, we can measure the speed of the object. Now, don't you think these Doppler radars can measure wind speeds? Because wind also change, I mean, there is frequency change when wind passes you by, passes these sensors. So these Doppler weather radars can be used over there, and they have very high accuracy. And we have a network of 40 Doppler weather radars, which will be increased to 100. So we will gather a lot of information. So that is one improvement. Okay. Then certain other facts. Number one, you remember I told you that the entire region will be divided into 3D grids. right? 3D grids. Now you might think of a grid like this. Okay, this is the ground and this is the height of the grid. Yes, cuboidal grid. But the 3D grid that is used in this model is called triangular cubic octahedral. It looks like this blue one. This is the ground and the height increases in a triangular form. This shape is known as triangular cubic octahedral, TCO. Okay, and let's not get into that many details because they won't ask you a question as to why this TCO is better for weather prediction. Okay, just remember that the shape of the grid is TCO and it is a superior shape of the grid, of the cell. Just remember this. Uses TCO dynamical grid system, enhancing the accuracy in capturing rainfall and other weather parameters. Just remember this, cram it, that the shape of the cell is this TCO and this is a superior way. Okay, that's about it. Now we are using supercomputers. As of now, we are using Arka supercomputer, which is with IITM Pune, Arunika supercomputer, which is with in Noida. Now, because we are using these supercomputers, which are enhanced supercomputers, forecast computation time has been reduced from 10 to 13 hours to 3 to 4 hours. So what the calculation that was done in 10 to 13 hours will now be completed in 3 to 4 hours. So it will give us quick update on data. Okay. Plus we are using AI and machine learning to enhance accuracy. Right? These are the only special features that you should know about. Now, what is the significance of using DFS? Now India will ignore other foreign models and use its own model. What is the significance of using DFS? Advantages basically. So it will improve accuracy. DFS provides a 30% improvement in forecasting extreme rainfall events like cloudbursts and all, and 64% enhancement in predicting monsoon rainfall. Generally, it is very difficult to predict monsoons. It is easy to predict winter rainfall in North India because these are western cyclonic disturbances. Okay, western disturbances. It is easy to predict that. But monsoon is really difficult. Even foreign models cannot predict monsoon rainfall. But this can. Okay, I mean the accuracy would increase. Then, well, EWS, early warning system, because it can give you localized data on extreme weather events like cloudburst and many others. You can develop early warning systems for blocks or villages so that advanced preparations can be done. Okay, so it will improve the accuracy of your early warning systems. Okay, then this gives India global leadership. Positions India ahead of countries like US, UK, EU by achieving 6-kilometer resolution, because these countries have 9 to 14-kilometer resolution in their global models. India will have small. So India is better than even US, UK, EU as far as BFS is concerned. And then there are other benefits. If your weather prediction is advanced, you can give advanced warnings to farmers. They can plan their crop cycle. You can do disaster management. Okay. You can support your infrastructure resilience or safety. You can also do water management, because if this weather system can predict that there is going to be no rainfall in the next 6 months or 3 months, so you can plan your water resources. Yes. And this data from DFS shall be shared with global researchers. So more research can be done on India's weather. So these are the advantages. Okay. And that would be all. With that, we conclude today's session. So thank you so much for watching, everyone. And well, I'm sure it has added value to your preparation, but it will add more value if you're regular with this lecture series. Sharp 9 p.m. every day you watch this lecture, memorize it from the notes, ask your doubts, and then give the test on time. As you all know, this is the last lecture of Geography and Environment. Therefore, the next thing is the test for Geography and Environment. Be regular with the test. I'm monitoring all your scores, so be regular with that. All right? And that would be all. We will conclude today's lecture at this. And I shall promise you to see you again. I am promising you to see you again with another topic, with another subject in this lecture series called Prelims Powerplay 2026. Thank you, everyone.